This is the video for example 8 and it follows on from example 7, this time looking at how weight percent calculations can be applied to sort of real life situations. And the question is how many grams of copper can be extracted from 150 kilograms of chalcopyrite. And this could be very important, for example, in a metal extraction industry, trying to find out how much yield they're going to get or how many grams of copper they're going to get out of a certain ore or a certain mineral sample. And there's two methods for solving these sort of questions. I'm going to show you both methods and you've got to decide what method's best for you. The two methods are weight percent or using moles. Both of them do use moles, one is more of a moles focus, one is more a weight percent focus. So let's look at the weight percent one first because that's more familiar to us at this stage. And step one, you want to find out what the weight percent of copper in this chalcopyrite is, and that's very similar to what we did in experiment 7 or example 7. So the first thing is, well, what's weight percent copper? Well, weight percent copper is just the mass of copper divided by the mass of the chalcopyrite times 100. In order to figure out the weight percent copper, we've got to know the mass of copper and the mass of the chalcopyrite. And so what we're going to do is, like before, consider we've got 1 mole of this mineral sample. And of course, the mass equals nanomoles times molar mass, because we're trying to find the mass of this mineral. We can say, well, we're assuming we've got 1 mole, so we've got 1 mole times by the molar mass, which is 63.55 for copper, 55.85 for the iron, and 2 lots of 32.07 for the sulfur. And you can put it in your calculator, and you'll find that the mass you've got in 1 mole of this mineral is 183.54 grams. The next thing to consider is, well, we know the mass of the mineral now. In order to find the weight percent copper, though, we also need to find the mass of the copper. So what I've got here is a little picture, and this picture is supposed to represent the mineral. It's got 1 atom of copper because there's 1 copper in the formula. It's got 1 atom of iron, the grey, because there's 1 iron in the formula. And it's got 2 sulfur atoms because there's 2 sulfurs in the formula. So for every one, I suppose we could say particle or 1 unit of this chalcopyrite, we've got 1 atom of copper. And if we've got 2 units of chalcopyrite, here we have the 2 units, that means we've got 2 atoms of copper. And it follows on, if we've got 1 mole of chalcopyrite, we'll have 1 mole of copper atoms, because you get 1 copper atom from every unit of the chalcopyrite. So what we can say now is that, well, if we've got 1 mole of the mineral, that means we've got 1 mole of copper. And therefore the mass of the copper is going to be nanomoles times molar mass, which is 1 mole of copper times by the molar mass of copper, tells me that in this 1 mole of chalcopyrite, which weighs 183.54 grams, I have 1 mole of copper, which weighs 63.55 grams. So now I can calculate the weight percent copper, which is just the mass of copper divided by the total mass of the mineral, times by 100, and it tells me that the copper in this particular sample, 34.62 weight percent, is copper. Now, that means if 34.62% of this mineral is copper, that means 34.62% of this 150 kilograms is copper. So what's the mass of copper at 150 kilograms? It's just that 34.62% of 150 kilograms, which is 51.94 kilograms, which is the same as 52 kilograms to 2 significant figures, but because the question asks us how many grams of copper, we've got to give our answer in grams, so it's 52,000 grams to 2 significant figures, and that is one way of solving the question. If you're answering this in an exam, for example, you wouldn't have to put this whole explanation of how there is 1 mole of copper in 1 mole of chalcopyrite. We did that here for your education. The next method, moles, we're going to go straight to a moles type method instead of using weight percent, and we're heading towards this, so in the future you might find yourself using this method more and more. The first question to ask is, well, I've got 150 kilograms, I want to figure out how many moles I've got. How many moles of chalcopyrite is that? And how to calculate the number of moles? Number of moles is mass divided by molar mass. So once again, I put my data down, I'm trying to find the number of moles. I've been given 150 kilograms of chalcopyrite, but there's a catch here. See if you think of the catch. Yes, that's right. The catch is in chemistry we use grams as our mass unit, so we've got to convert this from kilograms to grams. So that's 150 times 10 to the 3 grams, or 150,000 grams. And the next step is the molar mass we need of the chalcopyrite. We've already calculated it over here. So once again, it's just 63.55 plus 55.85 for copper and iron respectively, and 2 lots of sulfur. The molar mass is 183.54 grams per mole. So now we can calculate how many moles of this mineral we have in the 150 kilograms. Now, moles equals mass of the molar mass, which in this case is 150,000, divided by the molar mass, 183.54. Now you should put this in your calculator for practice, because you need to start practicing putting in these exponents in your calculator. And when you do that calculation, you'll find there's 817.26 moles of chalcopyrite in 150 kilograms of chalcopyrite. The next step is, well, if that's how many moles of chalcopyrite I've got, well, wait a minute, over here we said for every 1 mole of chalcopyrite we have 1 mole of copper atoms. So that means that if we've got 817.26 moles of chalcopyrite, how many moles of copper do we have? And yes, that's right, we've got 817.26 moles of copper. because for every 1 mole of chalcopyrite, we've got 1 mole of copper. And now because we know the moles of the copper, we can find the mass of the copper. Now mass is number of moles times molar mass. We've just calculated the number of moles, which is 817.26. We know the molar mass of copper from the periodic table, which is 63.55. So now we can say the mass of copper we're going to get is 51,937 grams, but to two significant figures, it's 52,000 grams, which is the same as the answer we got in the first part. So both these answers are equivalent. They both get you to the same results, except this one's more focused on weight percent, and this one's more focused on moles.